Solve the system. 2x minus y is equal to 9, and x times y is equal to 5. The first equation is the equation of a line, and the second, xy equals 5, is the equation of a hyperbola. Visualizing this, we know that there will either be 0, 1, or 2 points of intersection. To solve, we'll use substitution. We'll solve our second equation for x, and we get x is equal to 5 over y. Now we can substitute 5 over y for x in the first equation. When we do that, we get 2 times 5 over y minus y is equal to 9. 2 times 5 over y is 10 over y minus y is equal to 9. In order to eliminate the fractions, we'll multiply both sides of the equation by the least common denominator of y. So we multiply the left side times y, and we multiply the right side times y. Distributing y on the left side, we have 10 minus y squared, and on the right side, we have 9y. We'll now rewrite this so that we have 0 on the right side and we gather all the terms on the left side. When we do that, we get y squared plus 9y minus 10 is equal to 0. We can factor the trinomial on the left side as y plus 10 times y minus 1, which is equal to 0. By the zero factor property, we know that y plus 10 equals 0 or y minus 1 equals 0, which tells us that y is equal to negative 10 or y is equal to 1. Now we can find the corresponding solutions for x. We know that x is equal to 5 over y. So if y is negative 10, then x is 5 divided by negative 10, and thus x is equal to negative 1/2. If y is 1, then x is equal to 5 over 1, or x is equal to 5. So the two solutions are the ordered pairs, negative 1/2, negative 10, and 5, 1. We can check both of these solutions by substituting the x values and y values into the original system and verifying that they satisfy both of the equations. So the solution set is the set containing the ordered pairs negative 1/2, negative 10, and 5, 1.